please hit subscribe.
This problem appears at the qualifying examinations for applicants for Japanese government or MEXT scholarships 2020. There are two mathematics exams, one for social sciences, Mathematics A, and another for natural sciences, Mathematics B. This problem is from the 2020 Mathematics B questionnaire. The answer key and original questions are linked in the description. The problem reads, the angle theta, where theta is greater than 0 and less than pi over 2, between the two lines y equals 2 minus square root of 3x and y equals square root of 3 minus 2x on the xy plane is blank. There are three key ideas that might be useful in the solution. First is that the idea that the slope of a line on the xy plane is equal to the tangent of the angle that the line makes with the x-axis. The second is that the tangent of 2 times an angle equals 2 times the tangent of the angle over 1 minus the tangent of the angle squared. So this is an identity that's easily proven in trigonometry. And lastly, we will need the following triangle. This is a special triangle, a 30, 60, 90 triangle. And we will have to recall that if this angle here is 30 degrees or pi over 6, then the ratio of the sides of the triangle is such that the opposite side is 1 and the adjacent side would be square root of 3. And of course, the long side here would just be 2. For our convenience, let us define a few variables. So this is the given line, the first line in the given. Let's call that line L1. And let's call its slope, this is the slope, let's call that m sub 1. And we know that that is the tangent of the angle that it makes with the positive x-axis. And let's call that angle that it makes with the positive x-axis, let's call that theta sub 1. And for the second line, let's call that line L sub 2. And the angle that it makes with the positive x-axis, let's call that theta 2. And so we also call the slope of this line, this bit, to be m sub 2. Now let's just write down the angles, or rather the slopes, m sub 1 and m sub 2. So m sub 1 is just this expression from here. M sub 2 is just this from here. And we notice that m sub 1 and m sub 2 are negatives of each other. And the significance of that is that the angles that they make, with the positive x-axis are actually negatives of each other. And so we can say that theta 2 is actually equal to the negative of theta 1. If we draw that, this is what we mean. So this is just a sketch. So the angles, you see the angle here is a bit smaller than this, but actually we don't know that yet because this is just a sketch. This is not drawn to scale. Think of it as not drawn to scale. Now, we drew L1 to be the green line here and L2 to be the blue line. The reason for that is L1 has a slope of m sub 1, and we know that m sub 1 is positive. That's why the line is increasing like this. And the reason that it is positive is because 2 minus square root of 3 is positive. 2 is greater than the square root of 3. And to make that even clearer, think of the square of 2, which is 4, and the square of 3, which is just square of the square of square root of 3, which is just 3. So 4 is greater than 3. So 4 minus 3 is positive. And so 2 minus the square root of 3 is also positive. So we have that line. And then we saw that m sub 2 is just the negative of m sub 1. And so that line is decreasing. It looks like this. And theta 1 is the angle that L1 makes with the positive x-axis. And so this is theta 1 here. And theta 2 is just the negative of theta 1. And so it's this angle here. And so now we know what we're looking for. We're looking for the difference between the angles that these lines make with the x-axis, or the difference here. So we're just looking for the angle between the two lines. Okay, and it could be this angle or it could be this angle. So we're looking for the smaller of theta 1 minus theta 2. So theta 1 is this, is here, and theta 2 is this one. So from here to here, this is theta 2. So theta 1 minus theta 2 is just theta 1 minus the negative of theta 1, because we know that theta 2 here is just negative theta 1 here. So we're looking for 2 theta 1. That's this angle. Or we could be looking for the other angle, which is just pi minus this angle here. So pi minus 2 theta 1. And the reason we do not know yet is because we have not drawn this to scale. And the condition for the angle that we're looking for is simply 0 is less than that angle, which should be less than pi over 2. And we cannot say that from what we have here right now. So here we just rewrite what we already know. We have rewritten the slopes and the relationships, and this is the triangle that we might need to solve. And we see that this is what we're looking for, or this, whichever is smaller. Smaller because we want it to be less than pi over 2, or 90 degrees. So what we can do, because we now know this value, or we're looking for this value, and we have tangent of those values. Tangent of this is this, the tangent of this is simply that. So we can use the tangent function, in particular this identity, that the tangent of this angle here is 2 times the tangent of this angle over 1 minus the square of the tangent of that angle. And we use this because we know this tangent here, right? This is the value that. So we replace this with the value 2 minus square root of 3. We replace that and we get this. So in the numerator, we replace that here. In the denominator, we replace that here. Then we get this. And then we just try to expand the denominator first. So 1 minus this expression here. Then we simplify that. The denominator becomes, this is 1 minus 4 plus 3, which is 7. So 1 minus 7 is negative 6. And then minus 4 square root of 3. So that's positive 4 square root of 3. And you can see you can factor 2 out of the denominator. That's what we did here. So the 2's cancel, and we now have to rationalize this expression. That means we'll have to multiply both the numerator and the denominator by the conjugate of the denominator. And that's what we do here. The conjugate of this expression is this. So we just change the plus to minus. And when we do the multiplication in the numerator and denominator, we see this expression in the numerator and this in the denominator. The denominator is simply the square of the first term minus the square of the second. And now we can see that the negative 6 here cancels with the 6 here, and the negative 4 square root of 3 plus 3 square root of 3 becomes just negative square root of 3. And this 9 minus 12 becomes just minus 3. And so we get this as a simplified answer, which we can also write as 1 over square root of 3. And we notice, and this is actually what we're looking for. At the very beginning, we're looking for the tangent of 2 times the theta times theta sub 1, and we just write it here. And we notice that this is a special angle, this 2 theta sub 1, because this is a special value, and that is from this triangle. If you have pi over 6 here, then the tangent of this is just this over this. And so we conclude that 2 theta sub 1 is equal to pi over 6. And we're looking for the smaller between this and this. So what is pi minus pi over 6? Then that's just 5 pi over 6. So this expression is 5 pi over 6, and that's bigger. And so what we're looking for is this one, pi over 6. If you learned something new today, please help my channel by clicking the subscribe button and the bell for the notifications. See ya!